Number one, here's what I got from you. What'd you do to go through this? Latra. Cool. Like that. How'd you get the data and statistics? Control dot, cool. Sweet. I did something different for me, hold on. There we go, sweet, then what? Now, let me stop you right there. Victoria. Said what? You don't remember? Which one do I want? Oh yeah, so be careful there. Okay, cool. I don't know why that one's kind of selected. There we go. Okay, Victoria, are you tracking now? Can I ask you what to do now? Where to go from here? Menu, yep. Uh-huh. Yep. Go back to the problem real quick. What's it say? Oh, so which one do you think? You said, oh, 8. Yep. Bingo. There it is. Show exponential. Awesome. And here's our little equation. Okay. Well, it's not 2, it's what? I like your thinking, though. Because if it said 2, then I would just go 15.4, done. That's exactly how I would think, too. Okay, let's go back here. So, just pull up your scratch pad. I think I already typed it in up here. It is important, though, that you type it in exactly how it appears using as many digits as it possibly gives you, because even these are rounded. Even these numbers are rounded. Okay, so we got to type in every one of them, as many as possible. We have to be as precise as possible. I'm sure that Ms. McCarroll and others have taught you about precision. Precision versus accuracy. Accuracy means, yeah, you're right. Precision means, how much are you showing me that you're right? Exactly how much do you know? Well, I know that this is not just 6.0. This is 6.00037. And that matters here. Because when I type all that in and I put -2 in for x, I get 2.34. And I think, 5 of y'all said that? Half class said that? Didn't read. So a big takeaway from the problem, from this one, is you got to read the problem carefully, don't you? Because otherwise you're going to spend about 10 minutes trying all kinds of different formulas. Any other questions on that one? That's a tough problem. Okay, if you got that right, major kudos. Very well done. Okay, if you didn't quite get it right, don't be too frustrated. It's a tough problem. Really, really hard. Other questions on one? Number 2, anyone feel like they can come up and write what they got, explain what they did? I had you already. Probably can't steal the show. Nobody brave enough? Come on, shit. I already had one boy. Gotta have a girl. Yeah, she's up on the board. Make sure you explain a little bit what you're doing so we can follow you. You can bring your work up if you want.
Okay, figure.
If you move your head, there you go. Okay.
First term.
No.
No. Oh, okay. So figure.
Not quite.
She's ready.
Careful now. Y'all are making a fence post there. Be careful. Put that eraser on there carefully. There you go. Doesn't like it. Zero.
And then I do the first term minus 2.
No, not quite.
You do what it takes to get to 26 to 29.
Oh, so negative 26.
How do you get to negative 26? Yeah. How far apart are they? 17 apart. Is it a positive 17 or a minus 17?
Negative.
Good. Good job, y'all. Okay, excellent. Now, can you evaluate that? I just need your calculator real quick. So common difference, and then what do you do to get to the first term? Those are your two big things to figure out there. Good. Good, good, good. Okay, questions? Two tough problems. I mean, two really tough problems. So,
When you say A equals 1 always, why does it say A equals 10?
no, this down here tells you what term the series starts with. The series starts with the first term and it goes to the 10th term. N equals 10 right here tells you that there are 10 terms. So this is the number of terms or the last term, and this is the term that you start with for the calculation. Okay. Hey, listen. I was telling first period, I was saying this stuff. This is not like, we're not in Kansas anymore. This is some complex math. This is some complex math. It's not like ridiculous. I'm not going to blow smoke up your butt and say that this is like calculus or something, but this is tough. I said, I make this joke all the time, but I'm being serious. You know what they're doing at Sheffield? They're doing like 3 times 2, or negative 3x plus 7x. They're still doing that right now, combining like terms. I just got a new student from Kirby. Kirby's a decent school, right? Kirby's pretty good. Kind of out in the suburbs, too. I said, how's this compared to what y'all are doing at Kirby? He said, this is way harder. This is way more complex. So, don't get frustrated when it's hard. I expect it to be hard. I'm pushing y'all. I'm challenging you quite a bit here. Okay, I expect it to be tough, so don't get down on yourself when it's tough. Keep pushing through. All right, take your warm-up, set it aside, look at today's notes in 10, 9, 8, 7, 6, 5, 4, 3, 2, or settings. You can look in the settings if you want to. Alrighty, you can see our objective over there. I can solve exponential growth and decay problems. By the end of class, you should be able to do all these problems on the back. Okay, I expect you to be able to handle all these problems on the back, like 12 or 13. I'll quick pull you on one of them when we're finished. Okay. We're going to be doing the exact same stuff we did before. I'm going to introduce a slightly new formula. Same concepts, though, where x is in the exponent. That's why we call these exponential functions, because x is in the exponent. So from yesterday, do you remember what a stands for?
Oh,
A is the stretch, the vertical stretch. Yeah, you remember what it should be a capital B. Base. Okay. And then I got some new stuff for you here. So we can model a word problem with a exponential percent increase or decrease with the following formula. So you already know what's going to happen. There's going to be something in the word problem that tells you it's a growth or decay. Right here in this formula, do you see the plus or minus?
Yes.
If it's a growth, you're going to use plus. If it's a decay, you're going to use minus. Okay? Let's define what some of these variables are. Come in. What you got, boss? New student. What from? All right, Terrence, hold on. Terrence, go around this way. Grab that worksheet that's on the file cabinet and grab the calculator. There you go, Terrence. And just sit anywhere but the back row. Yeah, one of those, yeah. You got your worksheet? All right, cool. Hopefully you got a pencil. If you don't got a pencil, though, I got one for you. Pencil of shame. No, we can't pick on the new student on the first day. Capital A means the final amount. Capital A means the final amount. Can you imagine what lowercase a means? Yeah, beginning or starting amount. Yeah, the same thing, basically. All right, here we go. R is the same as it was before. Common what?
Ratio.
Common ratio. I bet you can guess what T is. Common time, is that what you said? Just time of work. Okay, and like I said, growth means we'll use the plus. Decay means we'll use the minus. Okay, so what you're going to do today, you're going to do a lot of look back up here at the formula, come back down. Look back up at the formula, come back down. Okay. Time could be days, hours, minutes, years. Could be any one of those. All right, let's go ahead and take a look here. You invest. All right, so here we go. We're back to our investing stuff. So you put $500 in the bank. It's going to give you 4% interest annually. So not very much, really. You can do a lot better than that in the stock market. In the stock market, you can get 10, 12%. So this is a low return. Okay, low return. But is this growth or decay?
Growth.
It's definitely growth. We hope our money's not disappearing. If it is, we are going to switch to a different bank. Okay, and if it's growth, that means that in the formula, we're going to use the plus sign. It says write a formula to represent the value of your investment after X number of years. After X number of years. So here we go, capital A. And we don't say A, we say the amount after X years. So when you want me to write that, you say the amount after 3 hours, the amount after X years, the amount after 5 days. Good. 500 is our starting amount?
Yes.
Nope.
1 plus.
Times 1 plus, now pause. We have to convert the percent to just a regular number. Okay, so 4%, close, 0.04. Okay, 80% would be 0.80. 75% would be 0.75. 2% would be 0.02. If I say it doubles every time, then that means you get another 100% every time. So it would be 1 plus 1. Does that make sense? If it doubles every time, that means you would get another 100%. Okay? You take what you have and get another set of that, so it'll double. So 1 plus 1. Okay? But in this case, we have 1 plus what? 0.04. To the, no, not t, after x number of years. To the x. Okay, so you remember beforehand, about a week or two ago, we talked about something called, the explicit formula, which just means basically the formula without x, the formula without the number of years, okay, the formula without plugging in the exact number. Okay. You cool, Terrence? Trying to figure something out? What's up? That's gonna take time. It's gonna be like when you're a baby and you crawled. You gotta crawl before you can walk and run. So, don't worry. When you need to use it, I'll show you. Okay, so get ready. Here it comes. How much money will be in the account after 6 years? So no, don't say A. The amount. Thank you. No.
The amount in 6 years.
The amount after.
After 6 years. Amount after 6 years equals 500 times 1 plus 104.
Or you know what we could say right here, if you want to. You know what else you could say here? What'd I do? Just added them up. You got a minute? Go grab it a minute. Just raise your hand. I'll get to you when I get to you. Yeah, Terrence. Nope. If you want to race her, bring it. When you type this in, let's see. So here I go, Terrence. I'm showing you how to use this calculator. You ready? Did you turn it on yet? Okay. Go to Scratchpad right here. Alrighty. What are we typing in? 500. 500. Parentheses. 1.04. Now for your exponent, you see me? Come on there. You see what I just pressed for exponent? All right, cool. What are we putting up there? 6? Yeah, 6. So what do I do? Do I round? What do I do? Because this is money. Why do you say monies? I'm trying to break you all these weird. Unless you want 632 cents in your bank account. Didn't we have that conversation? Listen. Yeah. Yeah, listen. So you put 500 in, and all of a sudden you come back. It's not 500 anymore. Well, 6 years, yeah. Yeah, because it's a low interest rate, and because you're not adding to it. You know, in a real life situation, here's the difference: you add to it every month. So you start off with 500, but then you put another 200 in every month. And in the stock market, you're not gonna get 4%. You're gonna get like 10%. Why? Because banks are a much more conservative investing market. In fact, banks are really only paying you interest. It's really like 2%, because what you're doing is you're letting them borrow your money. When you put money in the bank in a bank, you're saying this is my money, but you can use it to like give to other people and stuff. So for that, because you're letting them like store your money and use it, they give you a little bit, like 2%, 3%. Okay. Since you're letting them borrow your money to say, because here's what happens: you go to the bank, you deposit your check, and then another person comes through and they're making a withdrawal. They're trying to take money out to go make a down payment on a car, or to go buy groceries, or to go. Yeah, well, I mean, of course, you can't withdraw unless you got something in there. Yeah, Lewis.
Could they be used for real life?
Could what?
Could they be used for real life?
Of course. These are all real life situations. You don't want to bank on. Listen, going to like Bank of America and putting your money in a savings account, that's not good investing. Don't do that. If you want to really invest, you need to go to Charles Schwab or you need to go to Ameritrade. You need to create a mutual fund with a Roth IRA. Write that down if you want to. After EFC, I'm gonna give y'all a lot of investment strategies. Somebody said I never things I didn't learn in high school, blah blah blah. But I did learn how to do graphing a polynomial function. Thank you. You don't need that in real life, but there is some stuff that I will teach you after EOC. But we gotta be ready for EOC first. All right, let's look at this next one. The amount Y in grams of a sample of iodine 131 after T days is given by this equation. And notice, look at that. So they already did 1 plus or minus something. See that? We'll figure out what it is. So growth or decay?
No, it's decay.
I don't know. I don't see any negatives. Oh, that's just the name of the, what is this? It's a dash. That's the name of the sample.
But you take keys, you know it decays after a certain amount of time. So.
Okay. Anyways, why is it decay?
It's less than 1.
It's less than 1. I hope you heard that. You might want to write that down. If it's less than 1, it's a decay.
So 0.04 is greater than 1?
No, 1.04 is greater than 1. So what did they do here? They did 1 minus something. And let's figure out what that is. What is the growth or decay factor? I don't know. What is the growth or decay factor?
0.08.
How'd you get that?
90.91 minus 0.92.
Close. What you want to do actually is this. Take what they've given you there and do subtract 1.
Then I did it. Then I did 1. Then it gave me 0 there. Then I did 1 minus 0.08.
This isn't right though. Negative. Okay. Does that work every time? Yes. Subtract 1. Why? Because the formula starts with 1. Okay, so to find out what we started with, just subtract 1. Okay, this part of the problem right here is done now. We don't need that anymore. You'll see why. Estimate the initial amount of substance. Well, what's the initial amount? It's 50. How do you know that? It's in the problem. We said that the lowercase a part is the initial amount, the starting amount. Okay. All right, you ready? Let's figure out how much we'll have left after 5 days. So, that's all. The amount after 5 days is equal to 50.
Times 0.92. No.
I got 32.9.
32 point what now? 9?
9541.
No, just like this.
We do have new students, so let me remind you also, this is helpful. YouTube is your friend. I don't expect you to get everything we do the very first time. So, and I'm not saying YouTube type in exponential growth. I'm saying search Coach Matisse, find my channel, and look at the lesson again. And say, wait a second, what'd you say there? And rewind it and play it back. And then make a mixtape and make fun of me. I don't care what you do. But learn the material. If you subscribe to me, that would probably be smart. Say what? Not this. But yesterday's lesson I already did.
It's a microphone.
Well, yeah, it's easy. These have the computer has a built-in microphone. How do you Skype on a laptop? I don't know. How do you? All right. Do you think that you can do number 3 on your own?
I think so.
Okay, let's not do this one on our own. Tony, what's first?
Read it first.
Let's read it. So go ahead and read it, Tony. Great. Okay, Tony. Give me something. Give me something to start with. Give me something to start with. What do I start with? How do you know?
These staff members, once again, testing is critical. We have a number of students that's not attending. We ask for your full cooperation. Please monitor your yellow sheet dated Wednesday, February 26th, and allow those students to pass to the library immediately, quickly and quietly. Thank you.
Okay, Tony. Okay, now what?
You gotta do the alcohol. The alcohol.
Don't you get
The amounts. Okay, slow down now. Slow down now. All right, Tony. Thank you, Tony. Thank you for reading. Thank you for pointing out that it is a growth. Okay, Kenya, can you tell me what to do next? Okay, that's fine. So that's going to be what? Okay. $285 days or years or something? Let's go in order. What do I need next?
No.
Don't you figure out the years of 1985 and 1995?
Uh-huh. So next up I need time. So how much time has passed? 9 years. I really told her that. Kenya, can I come back to you now?
It's 1.75.
They will do 1.7. We right there tonight.
To the 9th power.
Wow. In 9 years, all of a sudden, this became a 70 what? Yeah, decimal doesn't matter. Feet, miles, gallons, inches, subscribers. Wow, so in 9 years they went from 285 cell phone users to 43,000. Does that seem realistic to you? That's pretty realistic. Over 9 years, over a decade, pretty much everyone got cell phones. That's pretty realistic. How you doing? Yeah, no problem. Tony? Oh, yeah. Do you need me to do one more with you?
Yeah, one more. This bacteria one.
No, I think you can do this one on your own.
He said something. It's something. This time about the
Quick poll, here it comes. I'll give you 12 times 10 seconds. Yep, this one's tough. This one's really hard.
Ain't no numbers in.
Read carefully. Oh, Terrence, my door open. Just leave it cracked. Exactly, that's okay. You have 90 more seconds. Hey, y'all getting way too cocky. Ready for a quiz? Let's do a quiz. Need to read carefully. Terrence, everybody's in the same boat right now. This is their first day doing this also, so look back up look at the formula, look at your notes. Just plug into the formula, people. Yes, there are. Man, I can trick y'all so easy. I just spell out the numbers and y'all are like, there's no numbers. All right, bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. So the rate is doubling. If we start with only 1 bacteria, which can double every hour, how many will we have by the end of 1 day, which is how many hours? 24. Okay, so here we go. The amount after 24 hours equals, it starts with 1. I already told you all this. If it doubles, 1 plus 1. Y'all want to cry and complain? This is not hard. Yep. Kevon is on his I don't teach the ACT kick right now. You said we don't do graphs. You don't do graphs. We done plenty of graphs. I don't know why y'all are still announcing your questions. Hello, look at my hand. I can see your hand. That's all you got to do. Just raise it. Tia.
Where did the second one come from?
The second one, because it increases, when it says it doubles, it increases by 100% every time. Okay, so pause. JJ, you got $5. Okay? If I double that, that means take your $5 and give you another 100% of that. So another what? Another $5. You said 500. 500 cents, yes. 500 cents. I knew what you were talking about. Okay, last one. Here's your final question, number 5. Quick poll coming at you.
You gonna buy some?
Yeah, by yourself.
I got it now. I don't get it.
I need everybody to get this problem right. Here it comes.
A stand for annual.
Amount.
Amount.
Too loud, sorry. Now, Terrence, here's what I want you to do. I want you to press home 55 on your calculator. Just press home 55.
With the house on
Dogan. No. Listen. I'm asking you a question. How do you spell your last name? Hogan.
You are 22.
Hey, y'all, shut up. Ugly, loud people. Okay, I'm gonna start just giving you zeros. That's fine. I said once, be quiet. Then I said, shut up. So if you don't understand that, then I don't know what's wrong with you. That's a problem with you, not me.
You guys have another problem?
No, just having the answer. Why would I want to see the whole problem? This is great. This is exactly why I love the quick poll. Okay, let's take a look. Because the question that I have is, what answers are correct? I don't know how some people got that, but all right. What's wrong with this answer?
You can't have 5, 6, 6.
Yeah. So all I want you to do, I want you to say $142.58. Okay. So this right here is the best answer. Let's see who that was. The other one said good.
You looked up on his phone.
Okay, if you didn't get that, do you have any questions? Last chance. Victoria.
Hold on. I had this on T. I just didn't put 1.03.
The money left in the count. I don't know what you mean. No, it means that you just put the money there and it stayed there.
How you get 1.03?
1 plus 0.03.
Why you put 1 plus? I thought we put it in the calculator like put 1.3 and 1 plus.
0.03, same thing.
I put 0.3 in parentheses. I ain't put 1.
No,
You gotta add 1.
That's why I got it wrong.
that's,
I would have had it right.
that's because you came to class late. You didn't see the
You
form.
right. Y'all hear me. Y'all know how to do it. I know how to do it.
So you see up here where it says 1 plus? 1 plus.
So what's the difference between decay and
Minus.
I got the note. You got the note? I got them. I got them. Go play.
Last chance questions.
Hey, give me luck. Give me luck.
Yeah, come on.
Throw it at.
Nah, it's time to put up the calculators. Calculators up.
Go play. Oh, I got it.